look at doing it graphically. So in the course of doing that, we'll review some basic calculator skills for you. So what I would like you to do, first of all, is do you see right here in that top row of buttons, right under the screen, do you see a button that says window? All right, I want you to press that button. And what the window does is tell you how much of the coordinate axis you're going to see. So I would like you to use, and again, your different problems will require different windows, but we're going to start with the basic window, the standard window. So I want you to hit the zoom button, see it right next to that, and I want you to go down to where it says zoom standard or Z standard, that's number 6, and press enter. And now, if you go to window, you should see that your X-min is -10, your Y, or your X-max is 10, your Y-min is -10, and your Y-max is 10. So -10 to 10, -10 to 10, -10 to 10 is considered the standard window. So you can either hand type those numbers in, or you can hit zoom 6, and that will always give you a standard window. I'm doing this so that we're all looking at the same picture. There's nothing magical about that window, but now we all have the same picture. So now I want you to press the Y equals button right there in the top row, the very first button, press Y equals. Got it? Now, somebody's been messing with mine, so I'm going to clear out what's in there. Okay. All right. Now we're going to put in for problem A, and again, we're going to do this problem 2 different ways. The first way we're going to do it is you're going to type in 2 equations. You're going to type in x squared minus 2x, and you're going to type in 3. So you're typing in x, and your x button, in case you wondered, is called your variable button. And your variable button is right here where I'm pointing. For me, it's right next to my alpha. You have a button next to alpha. Alpha is a colored button. Right next to alpha, it says x, t, theta on it. That's your variable button. So if you press that button, you should get an x. And then we want to square it. So you can either hit your squaring button, or you can raise it to the 2nd power using this. Whatever's easiest for you. I just hit the squaring button. And then minus 2x, and that's my alpha button again, or my next to alpha, my variable button. And there's my first equation. Now I'm going to hit enter, and my second equation is just going to be 3. Then I'm going to hit graph, right here in the top row. I'm going to hit graph, and you're going to see 2 things graphing. Did you see a parabola? That's your squared equation. And then you see your horizontal line, y equals 3. Now remember, in our equation that's on our paper, we want those 2 things to equal each other, right? So don't they cross each other in a couple of different places? So we're going to figure out where those places are. So we're looking for where they intersect each other, all right? So I want you to press second, it's actually calc. The button says trace, it's up there in that top row. So when you press second, it gives you the calc feature. And notice that one of the options is intersect. So go down to that intersect and press enter. You should see a cursor flashing on the screen. Okay, so what we have, let me see if I can sketch this somewhat. Okay, so I have something that looks like this. Now, the first curve you put in was this one. So the calculator is saying, first curve, question mark? Move your cursor using your arrow buttons. move your cursor so it's over here, somewhere to the left of the point this is the point we're looking for. We're moving it to the left, and it will automatically go on the first curve, so you don't have to worry about that. Move it over somewhere over here, anywhere over here, and press enter. Now, depending on your calculator, it will put some kind of mark there. Some of the calculators will actually draw a line. Some of the calculators put a little thing like this. But you have now you said, okay, I'm looking for a point that's to the right of this one. Now, move the cursor. It's now on the second curve. Move it so it's over here, on the other side of the point you're looking for. Okay, and press enter. Now, move the cursor till it's close. Doesn't have to be on it exactly, but close to the point you're looking for. Press enter. And down at the bottom, it will tell you that that point of intersection is -1, 3. Now, keep in mind, this is a nice, simple, easy equation. The calculator is going to be able to handle them no matter how ugly and hideous they are. Logarithms, e to the x's, sine, cosines, whatever. This is the strategy we're going to use if we want to find out where two curves intersect. Wait a minute, there's another point. So we start all over again. Second calc, so second calc, down to intersect. And now we want to move our cursor so that we're surrounding this point, right? So we're on our first curve, so move the cursor. Doesn't matter, just get it over here somewhere. It has to be to the left of the point we're looking for. So mine's right here, so I'm just going to hit enter. And then move it on the second curve, so it's over here somewhere. Now you've kind of surrounded your point, right? That's what you need to do, surround your point. And what's that point of intersection? That one's 3, 3. Okay, now, in terms of a solution, when you're solving this equation, you are interested in the x values. Does that make sense to you? X equals. So the answers to this problem would be x equals -1 or x equals 3. All right, now we're going to solve the same equation, actually, we'll do the second one a different way, okay? Oh, time out. This is an inequality. Oh, I'm so sorry. I know these 2 points now, right? I know these 2 points. I am not interested where they equal. I am interested in where the first curve is less than the second. So I know they're exactly equal at these 2 places. Isn't the first one below the second one there? So the answer isn't this. The answer is everything in between those 2. So as an interval, it's going to look the same, right? -1, 3. Everything in between those 2 numbers. This is a point. This is the interval from -1 to 3. Those are the x values. Those are the x values where the first curve, the parabola, is below, less than the second curve. When would I use brackets in my answer?
Yeah, when you have greater than or less than.
Yeah, if that then or equal to, right? Then I would color in those dots and we'll do that part. Okay, so one strategy, we're going to do another strategy for the second one, but one strategy is to graph each piece and then look for where one of them is below the other one, depending on what the equation is. So in this case, it was our first curve is below our second curve. All right, so that's one strategy. Now for the next one, I'm gonna do a little bit different strategy. And then you will pick which one you like the best, and that's what you'll do.
I forgot my calculator, so could I use like the Desmos Chrome thing on my iPad?
Nope, we're gonna bring a calculator. All right, so you lean over and look at your neighbor. Does she have one?
Oh, it's coming
Oh,
at the
we got the
middle of
delinquent
I know.
table here.
Yeah.
All right, scoot over and look. Do you have one? Scoot over and look at hers if you want to. All right. Now, so the strategy we just talked about is I would graph this. I would graph this. And in this case, I would look for where my first one is higher than my second one, right? Now, do I still need to find those points of intersection? Absolutely, because those are your boundary points, right? All right, so another strategy, if you like that strategy, go with it, it'll work every time. Another strategy is, let's go ahead and set this thing equal to 0. So move the 5x, move the 1. Then I'm gonna go to my calculator. I'm gonna clear out, oops. I'm gonna clear out the equations that I just put in, and now I'm gonna put in one equation. I'm gonna put this in right here. This is gonna be y equals x squared minus 5x minus 1. So y equals x squared minus 5x minus 1, and hit graph. Now, obviously, since I only put in one equation, I'm only gonna get one curve. It's a parabola. Looks something like that. Would you agree, keep in mind, this is how I set up my inequality. Would you agree that this and this are where the curve equals 0? And that all of this would be where it's greater than 0? So I just need to find those 2 points. All right? To find those points, which are x-intercepts, we use the same button. We go to second calc, but this time choose 0, because x-intercepts are where the function equals 0, so they are called zeros. X-intercepts are zeros. So press 0. Your cursor is going to come up, like always. You are looking, we'll find this one first, it doesn't matter, but we'll find this one first. You're looking for that point, so you'll go through the process you just went through. It says left bound, so move your cursor so it's somewhere to the left of the point that you want. So use your arrow buttons. Anywhere over here is good. Anywhere over here. Press enter. Move it then to the right of this point. Now don't move it too far. Don't move it over here. You have to be around this point. So just move it like over here somewhere. Press enter. Put it in between there. And according to my calculator, that point is about negative 0.19. It's a bunch more, but I'll just round it off. Is that okay? Now, repeat the process here. So second calc, 0, enter. Now we want to surround this one. So you're going to move your left bound over here somewhere. Your right bound over here somewhere. So left bound, move my cursor with my arrow buttons. Right bound. And then I'll put it somewhere in between those two. And what did you get for that point? 5.19? So if this had been an equals, the answer would be x equals negative 0.19 or x equals 5.19. But remember, it's an inequality. So we already agreed that we are interested in this piece of the curve and this piece of the curve. So what x values do we want? We want these x values? Oh yeah, we do. Don't these points have these x values? These are the x values we want. And these are the x values we want. So the answer to the problem is negative infinity to negative 0.19 or 5.19 to positive infinity. Remember, if you like labeled these points, wouldn't they all have x values less than negative 0.19? That's the answer to the question. Okay? When you do this, you can use either strategy. So real quick, what are the two strategies again? Leave them as separate equations. Then do second calc intersect to find where they cross. Or get a zero, plug in one equation, and look for the zeros. Second calc zero. Okay? Easy. All right, so that takes care of that. If something I said was confusing, then office hours tomorrow would be a perfect time to discuss that. There are going to be some equations, both of these we could have solved without a calculator, but there will be some equations where we aren't going to be able to solve them, and we're going to have to graph them. Okay, P3, due on Monday, right? Due on Monday, P3. P4, here we go. Slope of a line. If you don't know this, I'm probably going to come back and box your ears. What's the slope of a line? I mean, in terms of a formula. Well, it isn't really y over x. Some people say delta y over delta x. That means the change in y over the change in x. Right? What's our formula? How do we calculate it?
y1 minus y2.
You subtract your y's and you subtract your x's. The rule is, we don't care what order you subtract them, but they have to go the same order for both x and y. So if you do second minus first for the y, you have to do second minus first for the x, right? You can do first minus second as long as you do it for both. Point slope, form of a line. Oh, by the way, M is the letter we use for slope. What's the point slope form of a line?
Y equals mx plus b.
Okay, that's going to be the slope intercept form. So we'll go ahead and write that one down. The slope intercept form is y equals mx plus b. And the reason, Sydney, that is because m stands for slope and b stands for y-intercept. So when you have an equation that's formatted like this, you have your slope and you have your intercept. That's called the slope-intercept form. Okay, that's it's an important form. It's great. Back up, point slope.
Is that the one where it's like y minus y1 equals?
Exactly. This is Mr. Miller's favorite, people. He points sloped all the time. Y minus y1 equals m times x minus x1. That looks familiar. Yes, Mrs. Ford, we've seen that before a lot. Standard form of a line. This one we don't use use as much, except when you are doing substitution and elimination. This is how you normally see them. It's like AX plus BY equals C. So it's something like 3x plus 4y equals 7. That's called the standard form of a line. All right? That capital B right there is not the same as this B right here. These are just coefficients. A vertical line. What's a vertical line look like? X equals, very good. Vertical lines are not functions, right? They're not functions. X equals, so X equals 5, X equals 12, X equals something, so X equals a constant. All right, what about a horizontal line? That's a Y equals, and it is a function. Horizontal lines are functions. And then we got our intercepts. We want to get in the habit of thinking of intercepts as points. Isn't that what they are? Don't lines cross the axes at points? So we got to kind of keep in mind that the x-intercept is something comma 0, and the y-intercept is 0 comma something. No big deal there, but just remember they are points. They are not just regular numbers. What do you know about parallel lines? I'm not looking for a definition. In algebra class, what do we know about parallel? Same slope. So we have parallel, they have the same slope. What about perpendicular lines? Opposite reciprocal slope. So we not only have to turn it over and take the reciprocal, but you also have to take the opposite. So it's like a multiplicative and an additive inverse. Flip it over and change its sign. All right, so that takes care of the nuts and bolts of the definition stuff. Everybody okay with all that? You've seen it all before. Okay, now we're going to do some problems. You've done these before too. Find the slope of line AB. My nephew is having heart surgery today, and I hear my phone going off. I just want to check and make sure it's not my brother. It's going to take several hours, so I don't know anything yet. All right, so here we go. So, how do we do it? So Peter's up here saying -2 minus 4, which is great. But then on the bottom, he has to have -1 minus 3. So -6 over -4, you get 3 halves. All right, do the next one, do the second one. What's the slope of the second one? Undefined. We can't divide by 0, so it's undefined. What kind of a line is that? It's a vertical. It's not a function. It's a vertical line. It's a vertical line. No slope. Don't put 0. It's no slope or undefined. All right, 3. If the slope of AB is -7/5, and A has these coordinates and B has these coordinates, find X. Well, can you do that? Some of you are writing. Tell me what you're writing.
X minus 6. Over y minus 4.
Oh, that's interesting. Peter said he was going to use this slope and this point and write the equation of the line. which you can do, right? I mean, y minus 3 equals negative 7/5, x minus 6. That would be the point slope form of the line. And then he says, but I know y has to be 4, so I could put 4 right here and solve it out and get my x. I love it. It's a 2-step problem. Can we do it in 1 step? This will work, 100%. That will work. It's fine, it's great, it's awesome. Can we do this in 1 step?
Well, could you do, I tried it a different way and I think I could be wrong, but I did try to do like 4 minus 3 over x minus 6 would equal negative 7/5, but
No, wait, no but about it, Marin, that's exactly fine. Because 4 minus 3 over x minus 6 would be the slope, right?
yeah.
And we know the slope equals this. So basically you've got 1 over x minus 6 equal to negative 7/5. Can we solve that equation? Cross multiply, it's a proportion. So 5 equals negative 7x plus 42. Remember, that's a distribute when you cross multiply. Am I going too fast, getting too excited? You following here? So let's see, what is that? Let me do negative 37. Did you get 37/7? Which is exactly what Peter would get if he took this 4 and plugged it in right here and solved that equation. So either way is fine. Maureen, that's great. That's great. All right, good. Moving ahead. Here we go. Number 4. Number 4. This is not the lunch period, right? I'm confused, because last year didn't lunch start like around now?
It started, yeah.
That's what I thought. I'm glad it doesn't. I'm glad it's later, but I'm still kind of programmed for last year. All right, next, we want to write the point slope form of the line through these 2 points. And I erased it, but we just reviewed what point slope looks like. What do we need to do?
Find the slope.
Find the slope. Kids, you cannot write the equation of a line without the slope. You gotta have the slope. So let's find our slope. Did you get negative 3/4? Now, if I'm gonna do the point slope form of the line, then I need to pick a point. Doesn't matter which one I pick.
No.
Nope. So I think I'll just use that one since it doesn't have any negatives in it. Doesn't matter. Pick whatever you want. Y minus 1 equals negative 3/4 x minus 6. Done. That's the point slope form of the line, right? If you needed to graph this line, you could absolutely do it because you know that it contains the point 6, 1, right? And you know the slope is negative 3/4. So down 1, 2, 3, over 1, 2, 3, 4, and there would be a picture of your line. Point slope is beautiful, beautiful. All right, next one says do the same thing, but write this one in standard form. All right, so what's your thought about that? Standard form, remember, is the one that looks like 3x plus 2y equals 9. That's what standard form looks like. So what do you think we ought to do? Here. Sabrina?
You can soften the slope.
Gotta find the slope. Let me say it again. You can't write the equation of a line without a slope. You gotta have a slope. So slope is 2 minus -3 over 6 minus 7. Oh, that's nice. Did you get -5? Okay, no fraction. That's good news. Now, can we do this and then just rearrange things so that it looks like that? So we don't have to learn anything new. We'll pick a point, y minus 2 equals -5, x minus 6. Y minus 2 equals -5x plus 30. Y equals -5x plus 32. 5x plus y equals 32. Done. So it isn't a matter of doing the problem differently, it's a matter of writing the answer differently. Mhm.
So is it basically just like doing the same thing we did before, but you solve it?
Um,
I mean, not fully solve it, but
Well,
like
I chose, somehow I have to end up with this format, so I chose to get y by itself, so I solved for y and then move my x over, yes. Procedurally, you're writing the equation of a line. What is different is how you're presenting your answer. This line, and this line are all exactly the same line. We just have it in 3 different forms.
Wait, can A be negative in this or no?
Technically, no. There are some rules about that. I am not gonna get all hung up about that. We don't use standard form hardly ever. But yes, technically, A is supposed to be positive, which is easy to fix. You just divide 2 by negative if it works out that way. All right. Would you do the last one? So you're gonna repeat the process, but you're gonna stop right here, because this is slope-intercept form. So you're gonna do the same kind of thing, but you're going to make your answer look like this. Got some fractions to deal with, unfortunately. If I did it right, we got some fractions. Anybody have an answer yet? It should be y equals. Ms. Coleman, got an answer?
3/5 x minus 4/5.
That's what I got. That's not what I got. Who said that? Okay, did you get 3/5 for your slope?
Yeah.
Okay, so did you say y minus, what did you say, which point?
I did the first one.
So y minus 4 equals 3/5 x minus 8?
Oh, I subtracted the 4, not added.
Okay. You mean to the other side?
Yeah.
Anybody else have a question about that one? Okay. Now, let's write an equation for the line containing 3 -2 and parallel to this one. Now, it doesn't tell me how to express my answer, so you can express it however you want. It doesn't tell how. So Allison, what do you think?
I would. Could you put, so you have the slope and you want the same slope, so would it be y minus, or technically y minus -2 equals 4, parentheses x minus 2.
Beautiful, so this will become y plus 2?
Yeah.
Now, if you're okay with point slope, we're done, right? That's the point slope form of a line. If you want slope intercept, then you would work this out and get y by itself. If for some odd reason you want standard form, you would work it all out, get y by itself, and then move your x's over. That's easy. How about 8? Same thing, except we want to be perpendicular this time. Isn't that it? Isn't it that easy, guys? If we want to be perpendicular, we need the opposite reciprocal slope. Point stays the same. Done. If you're okay with point slope form. All right, now let's do some fun things. Given all this stuff, find A and B, so the quadrilateral ABCD is a parallelogram. Take a minute with your partner and start sorting that out, would you?
Okay, let's find.
Which is parallel. They just have to figure it out.
Those are the parallel.
Yeah, let's go back, because I don't think it'll always be perpendicular, you know what I mean? If you
Oh, it has to be cut over two. Oh,
Yeah, no, you're right, it's not.
So we could do, I like to see if I can find.
Oh, we're supposed to find.
Find the social points between them and see the opposite.
Oh, it's
I was like, we don't know which point. So like, A to B would be
I guess 5 2.
0 minus 1.
No, it can't be 2. Maybe negative 5.
It'd be down 2. It'd be 2 negative 5.
that has to be five.
No, that's.
No, that's right. And then I can do that.
If you look at the sheet times,
now that we have. I can just throw that.
Oh, it's good here. Oh my gosh. Or C is in. Yeah, it's the whole.
Oh, wait, I didn't even think of what
Now, did everybody pay attention to the ABCD?
Yeah.
Okay, that's important. When you label a quadrilateral, ABCD, the vertices have to be in that order, okay? So if this has to be quadrilateral, A, B, C, D, doesn't C have to be out here somewhere? Because you are doing A, B, C, D. Okay, so what'd you come up with? Did you come up with coordinates up there? Kind of just look at it, what do you think? Aren't these two parallel? Aren't these two in a horizontal line? Don't these two have to be in a horizontal line? So doesn't that Y have to be 5? How many steps did you take here? What's that? Yeah, 4. So you
Still made it parallel.
You get 6, 5?
Yeah, we got it.
Still made it parallel. We need to get.
Okay, wait a second.
Oh, yeah.
Wait a minute, we have first of all, would this point create a parallelogram? Okay, now, Dom says, could there be another one? So, Dom, what did you say you think it might be?
Why couldn't it be -2, 5?
So he says, why couldn't it be -2, 5? So -2, 5 would be right here. And that would be point C, right? So if we're gonna form parallel, or it's gonna be a parallelogram, but A, B, C, D, we have to join them in order. So A, B, C, D.
But why you have to join the order?
Because that's what ABCD means. Yeah, now if it just said, find a point so that those 4 points make a parallelogram, you'd be all good. But when it says quadrilateral A, B, C, D, they go in that order.
I got both, -2, 5, and
Yeah,
6, 5.
yeah, and that would be right. And in fact, I'm not even so sure there wouldn't be more if we were allowed to join them in any order. Maybe there's just 2, I don't know, I'm thinking there could be more. But we're not allowed to join in any order, we have to go in the order they say. Okay? All right,
You guys are in the box, Travis.
next, write the equation of the line tangent, oh boy. Tangent to x squared plus y squared equals 25. Boys and girls, what is x squared plus y squared equals 25?
Perfect.
It's a circle centered at the origin with a radius of 5. We're supposed to know that, right? We talked about circles the other day. So we're centered at the origin with a radius of 5. So I'm sure this won't look very good, but I'm going to try to draw a circle centered at the origin with a radius of 5. All right, there it is. There's my circle. Now, there's a point on this circle that's -3, 4. Looks pretty good. -3, 4 right there. There's a point on that circle. Your job is to write the equation of the line tangent to the circle through that point. You remember what tangent means. Tangent means just touches it. All right, so spend a moment with your partner and see if you can come up with a plan. Does everybody understand the problem? This is the problem. You're writing the equation of that blue line.
6 or not the word, the point of the y intercept.
This is cool. When it comes, like, tangent in this case, doesn't it just mean that it, like, intersects?
So the slope is 2/3. What do you want to say? What's up? I said 2/3.
All right, this is gonna require you to remember something from geometry. Lewis, what do you think?
It feels like if you find the slope, you just plug that into point slope formula.
That's exactly, I mean, I'm writing equations live, so I have my point. I just need the slope, right? And some of you are thinking, wait a minute, I only have 1 point. Because I do, I only have 1 point, right? How in the world am I supposed to find the slope with only 1 point? Alexis? Exactly. Kids, would this be a radius right here? And what did we learn about a radius and a tangent? They are always perpendicular at the point of tangency. So, am I supposed to know that? Yes, you learned it. From, who'd you have, Hastings Smith in geometry? Alice, whoever you had, you learned it. Now, we're writing the equation of the line, we need the blue slope. But we cannot find the blue slope because we do not have enough information. Can we find the purple slope? Yes, because we have 2 points. So -3, 4, and 0, 0. The purple slope will be -4/3. Did I do that right? Yeah. So if the purple slope is -4/3, what is the blue slope?
3/4.
3/4. And then we can write the equation of our line because we have everything we need. Y minus 4 equals 3/4 x plus 3. Okay. All right, number 11. We're not going to get this done probably, but we'll get started on number 11. Americans' consumption, okay. Write a linear equation for spending in terms of the year using the first 2 points in the table. Now, it is important that you understand that given a data set like this, you may not always use the first 2 points in the table. You might use the first one and the third one or something like that. However, the equation I get with points 1 and 2 will be slightly different than the equation I get with points 1 and 3, because chances are these, 6 points don't lie exactly in a straight line. Do you get that? So you're not going to get the exact same answer unless you use exactly the same points. So they're telling us we got to use the first 2 points. Okay, we can do that. We can do that. So spending is the Y, year is the X. So we can do 1998, comma 5.9, and 1999, comma 6.3. Would everyone agree with that? So we're going to write the equation of the line. So first things first, what do? slope. So 6.3 minus 5.9, 1999, 1998. Did you get 0.4? So y minus, I guess I'll just use the first one, 5.9 equals 0.4 x minus 1998. Because there's another step to this problem, would you go ahead and get this in slope-intercept form? So y minus 5.9 Okay, I don't know if I did my arithmetic right. Double check, this is what I got. Now that is the answer to A. This could also be the answer. This is a point slope form. I asked you to get that because of the stuff that's coming in the rest of the problem. Everybody with me? All right, we're gonna do the next part and then we'll have to stop. Use this equation to predict the spending in 2002. So what would you do? Keep in mind, this is what your points look like. So you need to predict the spending in 2002. So what are you gonna do with your 2002? Put it in for X. So Y equals 0.4 times 2002 minus 793.3. So let's see what we get. Did you get 7.5? Now let's compare that with the actual data. The actual data was 7.4, which means our line's okay. I mean, it's not perfect, but it's okay. And please do keep in mind that that isn't $7.5. That's $7.5 trillion, right? So that would be your spending. Okay, so tomorrow we'll pick up there. If you need to rent a calculator, or you don't really rent, you need to borrow a calculator,